Hey, good morning. This is a video to help you with continuous interest. I wish I was going to be there to talk about it because it's such an exciting math idea. Infinity and beyond. All right, so first I'm going to share a screen with you. Let's see, I'm still rusty at this. Okay, so here's where we are. We don't need to see my face here. Let's move this up. Okay, this is the handout that you picked up, and I'm going to go over this first page of the handout, and which it describes how to get to continuous interest. Okay, and then there's a few problems. There's a few problems to go through on the next page, and then you have a delta math assignment. All right, which covers all the compounding stuff that we've been talking about. All right, so I'm going to talk about do a little math here, continuous growth or interest. All right, so yesterday we talked about this principal 1 plus r over pink n times t. All right, and we looked at this n being could be a 2 for semi-annual, it could be a 4 for quarterly, or even a 12 for monthly. All right, and but what happens when this gets to be a very large number? What happens? Does it increase? Does it increase forever? And yesterday we saw that we had it increased when it went from annual to semi-annual and from quarterly and then to monthly. But the difference between these two, between quarterly and monthly, was kind of small, right? Where the difference between the other ones was really noticeable. And so does it increase forever? Does it increase forever? All right, and so we're just going to do a little math trick here. I know you love math tricks. Oops. There we go. All right, so we're going to do a little math trick here. All right, because I want to focus on this n. All right, so focus on n. It says focus on n. All right, so I'm going to do a little math trick to isolate n. So I'm going to create a brand new variable, and since this is r over n, right, and I want to get rid of this r here, so I'm going to make a new variable called x is n over r. All right, and then if you do a little math on that, you get r is, sorry, write it the other way. Makes more sense. All right, so now, so I can get n is equal to x times r. So if I multiply both sides by r. All right, so now I'm going to come over here, and I'm going to do something. So first, we're going to ignore this p for now. All right, and we're going to imagine that it's only a 1, so it disappears basically, right? And so then we have 1 plus r, and so I'm going to take this, what color should this be? Purple. Purple. All right, so I'm going to take this purple xr. That didn't work. Purple, done, there we go. I'm gonna take this purple XR and I'm gonna put it wherever I have an N. All right. So what is happening with my, there we go. All right. And so I'm going to take this XR. And so here's N. So I'm going to put XR there. All right. And I'm going to put XR here. And I'm going to leave the rest of it the same. All right. And so that's a T. All right. Now notice that these two now cancel out. All right. And so I can rewrite this as 1 plus 1 over x to the x, and then put this RT on the outside. All right, so fun metric. If you want to watch it again, just replay the video. All right, but now I can look at this piece. All right, so now I have this P and times this thing, 1 plus 1 over, now I'm going to put the N back because it doesn't matter whether I use an N or an X. All right, and RT. And it turns out this is what's called an infinite series. And we're going to say, what is the limit? What is the limit as N approaches infinity of this 1 plus N over N? All right. And it turns out you can look at the handout for a little bit more detail, but it turns out this is a very a constant. All right, and this is called Euler's number. I mean, a guy named it after himself. E. All right, and Euler's number is a number just like pi. It's actually equal to 2.71 something. It's an irrational number, and it's on your calculator. All right. So it's just like any other number, like you would put in 2 or 7 or 8. All right. And it's on your calculator, and the button looks like this. It has pi on it, and E and I, and you have to toggle it to get to the E. All right. And so now here we have this. So I'm going to write all this stuff again. 1 plus 1 over N. And like this, and RT. And so now we're going to substitute E for all of this. And so our new formula for continuous interest is equal to P times E and to R times T. Okay. Pretty cool. All right. So let's look at our assignment for a sec now. Now that we have that cool little formula right there, okay, where we substituted E for that continuous function after we fooled around with it. All right, and so let's look at here. So we have P, and what is the interest rate? So the interest rate in decimal, all right, so it says percent here, but don't put the percent there, 0.35, and it's paid continuously. All right, and so the same here, 1,500, and the interest rate is 0.025, and it's paid continuously. All right, so let's look at one of our problems here. Joyce Chase deposits $400, and it's continuously, so that's going to be this E. All right, and it's 3.5%, and so we're going to say 3.5%, sixth grade math, is equal to 0.035. So we're going to put 0.035, and it's going to be times 4. Well, actually, the model is going to be T, right? The model is going to be T. All right, and then here it says that our time equals 4, so we have T equals 4. So in the calculator, I'm going to put 4. I'll just write it out here. You don't need to write it out. I'm going to put 400 E 0.035 times 4. All right, that's what I'm putting in my calculator. All right, so I have picked up one of the calculators, doesn't work. All right, so now I have 400 times E, and I have to hit toggle twice to get E. And then I have a 0.035. So this is an exponent, right? Times 4. And that turns out to be equals $460.11 when you round it. All right, let's do another one. All right, this one's going to be 1100 E, and 5.25 is going to be 0.0525 T. That's our model. All right, and then we want, what does this look like when T equals 9? All right, I'm doing this. I hope I'm doing this right, because I have no one here to check my work, and you guys know I make mistakes. So if I end up being, all right, 0.0525 times 9, and I got 1764.40. Okay, so there's a couple more practice problems on this page. All right, and stop sharing so you can see my face. Okay, and you have a Delta Math assignment. It's called 2.2H. I think it's called compounding, and it's all the different types of compounding: monthly, quarterly, semi-annually, and continuously. And so that's your assignment for today. So good luck, and I'm sorry I'm not seeing you today, actually, or tomorrow. And so tomorrow, let me since I'm not going to be here, let me go through this. So here we are today. All right, here we are Wednesday. All right, and we're doing continuous functions, right? Continuous interest. All right, tomorrow, Thursday, this is a review day of all the stuff we've done so far. And then I realize I'm talking about this. All right, there we go. All right, so Thursday's a review day. So this is review day. All right, and then Friday's a quiz day, and the quiz is short. So the quiz is going to be in 2 parts. First, I'll give you a practice quiz, and then the actual quiz. All right, and that's what we're doing today. And I will not be with you again tomorrow, but I will have review material for you. All right, stop share. You guys have a great day, and I will see you on Friday.